Hey guys, so today we're going to be talking about the distance between 2 points as part of coordinate geometry and linear relationships. The learning intention or aim of this video is for you to be able to calculate the distance between 2 points on a line using the distance formula that we're going to go through. So, what exactly does it mean, distance between 2 points on a line? Well, a straight line that's in the form of y equals mx plus b will have an infinite amount of points on it. You can never stop with how definite you want to go with how many points there are on there. So if we're given 2 points, we can calculate the distance between those 2 points by using the distance formula. So the distance formula is quite simple. Once you've done it a few times, it's very simple to do. So it may look a little bit confusing. Don't get overwhelmed by it. Let's have a look at what the distance formula is. Let's look at the things you need to look out for, the steps, and then we'll do a few examples and bring it all together. So the distance formula is shown with a small d, and it says equals the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And don't worry if you don't understand what x2, x1, y2, y1 is. We'll go through that in the example. All you need to know is that's a formula and we substitute into that. Now, one thing you need to be careful of when using this formula is when you have negative values or negative coordinates, you need to be very careful of how you substitute them in because you have a minus in between each of these. So if x1 is a negative, it's going to be negative, negative. And when we do a few examples, it'll make sense what I'm talking about. Now, I like to do each of these sections separately. You'll see that in the example. However, if you're going to do it all at once in the calculator, make sure you use your brackets properly. So let's go through the steps. So you're going to have 2 points, and that means there's going to be 2 x values and 2 y values. So we have to differentiate them. So one of the points, and it doesn't matter which one of the points, you label as x1 and y1, and the second point you label as x2 and y2, and it doesn't matter if they're swapped over. After that, we substitute those values into this formula, and then we simplify and we round off. So let's go through a few examples, and it's important for you to write these steps down just so you can look back and see what we've done in each example. So I'm still going to leave the formula and the steps up there just for example 1, and then I'm going to move the screen up. But let's have a look at it. It says, calculate the distance between the points 3, 6 and 7, 3. Now step 1 is label one of the points x1 and y1, and the second point x2 and y2, and it doesn't matter which one. So just for continuation, I did the first one as x1 and y1, and the second one is x2 and y2. Okay, we've done that. Step 2 says, substitute these values into the formula. So the formula is distance equals the square root of x2, which is 7, minus x1, which is 3. So you have 7 minus 3 all squared there, plus y2 minus y1. So plus y2, which is 3, minus 6 all squared. You'll see I've substituted it into the formula there. Now you can type this all in the calculator at once. If you are going to do that, just make sure you have brackets around the whole thing under the square root. But I like to do it step by step. So 7 minus 3 is 4. So we have 4 squared. And 3 minus 6 is negative 3 squared. 4 squared is 16. And negative 3 squared is 9. Make sure when you have a negative 3 squared, you put the negative 3 in brackets. With some calculators, like the Casio one, will interpret this differently with or without the brackets. So then I simplify underneath furthermore. 16 plus 9 is 25. And then the square root of 25 is 5. So I like to go step by step through. But if you type all of this in the calculator, you'd get the same answer as well. Let's do a few more examples. Let's look at example 2. So example 2 says again, calculate the distance between a point and the origin, correct to 1 decimal place. So the origin in a Cartesian plane is 0.00. So if I look at this Cartesian plane here, origin is right in the middle there where you see that red dot. So I've written the coordinates 0, 0 there. Now, just like the steps say, label one of them x1 and y1, and the second one is x2 and y2, which is the origin there. After you've done that, substitute into the formula. Now here, it's very important to see I've used y2 minus y1. y2, 0, minus 4. Now it's very important to use the brackets there because this minus, as you know from directed numbers, will become a positive. So 0 plus 4, which is 4. And 0 minus 3, which is negative 3. Again, simplify. Negative 3 squared is 9. And 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. So you can do all of these step by step, bit by bit, and get to the answer. As I said, the more that you do of these questions, the easier it becomes because it's a very simple procedure. Let's look at example 3. Now with example 3, I have 2 points, but I have some negatives there, so I have to be very careful. So it's the square root of x2 minus 2 minus 6. And you see how I laid that out. Avoid silly mistakes. Always show all you're working out, just so you can go back and have a look if you made any silly mistakes. And the next one is y2 minus y1, 5 minus 3. And then I have 4 squared plus 2 squared, 4 squared being 16, and 2 squared being 4. 16 plus 4 is 20, and the square root of 20 is going to give me a decimal. I'm rounding that off to, as the question says, 2 decimal places. Now let's do one final example, but in this case, I haven't been given the coordinates in a sentence, I've just been given a graph. And on the Cartesian plane there, I can see that it says calculate the distance between A and B, A being there, B being there. Now, this black is my working out, so that hasn't been given. So the first thing I need to do is I need coordinates so I can label them as x1, y1, and x2 and y2. So I identify the coordinates here. For A, crawl before you climb. So I crawl to negative 4 and I climb to 2, negative 4, 2. And for B, I crawl to 3 and climb to negative 3, as you can see there. Now I have 2 coordinates. Now I can label one as x1, y1, x2, y2. And again, it doesn't matter which one's which, you'll get the same answer. So here, once I've substituted it in, I have to be very careful with my negatives. 3 plus 3 squared is 9 squared. Minus 3 minus another 2 squared is minus 5 squared. 9 squared is 81. 5 squared, or minus 5 squared, is 25. 81 plus 25 is 106. And I rounded this off to 2 decimal places. Even though it hasn't told me to, you can round off to whatever you want, as long as you write next to it what you rounded off to. So if the question doesn't indicate rounding off, you can round off to 1 decimal place, nearest whole number, whatever you do, as long as you write next to it what you rounded off to. Hopefully those examples made it a little bit more easier for you to understand distance on the Cartesian plane. I have a few questions here that I'd like you to do. Pause the video, give these questions a shot. Make sure you show all you're working out. Be careful of your negative numbers, and write down the steps and the formula just for reference. Unpause the video, come back, and hopefully you get all the answers right. Okay, there's my recommended answers. Hopefully you got that all right. Have a read through it. Go through it step by step. If you got anything wrong, go back and look at the video again just to make sure you haven't done any silly mistakes. Till next time, take care, guys.